Hello, this is Itsu. Okay, I see there is some misunderstanding about the input and the output, especially when using some bulbs and some loads. I hooked up again my Mozilla with the yoke, and instead of one 40 watt bulb I hooked up my 1 kilowatt load, which is 10 bulbs, 100 watt, 220 volt each. But of course this is impossible, so I removed 8 of the bulbs. I only have 2. These are all disconnected. I have only 2 100 watt bulbs, so meaning 200 watt lamps connected. And I will try to show you that when they light up, they're not really pulling 200 watts. We will be monitoring the input with the power supply. It's set at 17 volts at the moment, but we also will be using my fluke meter, to measure this DC and also the current, so we can calculate the input. And we have a 2 RMS meter across the output, but we will see that even this fluke meter is not accurate at the 16 kilohertz. It will show 240 volts while the scope will show much less. I also have hooked my scope, the yellow probe, across the output, measuring the voltage RMS, and I have my current probe also hooked up in one of the leads, measuring the current. And then we let the math function calculate the wattage by taking the yellow voltage times the green is the current. The current probe is set to 10 milliamps per division, but that's needed because I use the external current controller, which is set at 1 amp per division. So we have to recalculate the output from the green trace and also the calculated output from the wattage. We have to take it times 100 to get the real wattage value. Okay, let me hook up the power supply, if I can do that with one hand. Okay, so we have the 2 100 watt bulbs lit. This meter says 241 volts AC at 16 kilohertz, which is not correct. The power supply says 17 volts at 9 amps, but the fluke meter says 17 volts 1699 at almost 9 amps. So we keep that as a input, and I will freeze this frame. Let me measure the temperature of the MOSFETs. They get slightly warm, 40 degrees. Not really. But so this is able to run the load. I will disconnect anyhow. And we can see that this is the freezed frame. We can see the yellow trace is the voltage across the bulbs at 16.5 kilohertz, and you see it's 159 volts RMS. So not the 240 volts measured by the multimeter. And that's because of the higher frequency. and we can see that the current, the green trace, is 7.26 milliamps. We have to take this times 100 because of the setting of the current probe. So we have 726 milliamps RMS, and calculated wattage is set here 1.14 watt, but we also have to take this times 100, so it's 114 watts going into the two bulbs and not 200 watts. So if you take the input 70 volts times 9, it's 153 watts input, and we have 140 watts output, and we can calculate the efficiency here, which will be 70% or something. I will do that later. Okay, I hope to have cleared up something, and not to use multimeters at higher frequency, or not to use, like said by several people, not to use bulbs wattage as a indication of the load. Thank you for watching.